Yeah, that's not bad. You could ask a question. Sorry, I'm fighting I think it's an allergy, not a cold, but. All right. So, relationship, heart rate versus height. Okay? All right. So, is that a good scatter plot? Pretty good. Okay, so I've done part A. Calculate the correlation coefficient. How do you do that?
Is that the?
Okay, while you're thinking about that, let me save this really quick. Hopefully I can get it on here. No, we'll keep going. Go ahead and. How do you calculate the correlation coefficient?
You'd right click on one of the points and hit add trend line.
Do what?
You'd right click on one of the points and click on add trend line.
Okay, that's not the correlation coefficient, that's later on.
Isn't it like data
Add trend line, that's actually step D that you just did,
Isn't it like
not step B, which we can do, we need to do it.
data minus mean divided by standard deviation?
Yeah, do you guys have that memorized? R equals no, 1 over n minus 1 times sum of xi minus x bar over s of x times, same thing for y, yi minus y bar over s of y. Now you may have been saying that conceptually, but this is the actual equation. Okay?
Can you talk that out one more time? So
Okay. So that's basically data minus the mean over the standard deviation, right? This is for the x term and for the y term, it's the same thing. Okay, and then we're dividing that all by n minus 1, where n is,
So are we multiplying the two, or are we adding?
yes,
Multiplying, so that's not an answer. Are we multiplying them, or are we adding them?
we're multiplying before we add them.
Okay,
So we're doing both.
so you multiply together your answer for the data minus the mean over the standard deviation for x.
We're going to go through it right
You'll
now.
multiply the x and the y.
Okay, so let's go through the steps. So here's the equation. Okay, here's your equation. Okay, so who can talk me through doing this?
You'd find the mean of x and y data.
Okay, so the first thing we need to do is find the mean of the x and the y data. We do that.
Average.
Average. And same thing there, right? What else do we need to do?
And
Standard deviation.
Standard deviation.
Find the mean of the standard deviation. Can we do it that way, or do we have to do it the wrong way?
You can do it that way.
Okay.
Standard deviation, I'll let you do the short way too.
Mm-hmm.
How do I find the standard deviation?
STDEV.
FTDEV of all of that. Standard deviation of 3.5 and 1.9. Okay.
What's the example for the standard deviation?
What's what?
Just the code on Excel for the standard deviation.
STDEV. Oh, it worked. Okay, one other thing that I want to point out. This is the exact same thing. I just hit the save button. Now, one of the other things I want to mention here, let's say that I don't have my access titles. I'm just going to back up for a second. Let's say I don't even have a title in here, okay? This is one of the differences. This is what your version of Excel may look like in the testing center. Notice when I click it, there's no green plus sign here, okay? So how do you get access titles if this is the version of Excel that you have? Nope. You've already clicked on this. You're going to go to Layout. You're going to go to Access Titles, Horizontal. You're going to do Title Below, and you're going to do the same thing. Access Titles, Vertical, Rotated is what you're going to want. And if you want to do a chart title, you can do it above the chart. Okay? So that's a little bit different.
The computers in the testing center have the little thing.
Oh, they do have the green plus?
Mm-hmm.
Okay. Well, in case you get this version. Okay, so the green plus, if the green plus is there, you'll be okay. Okay? If that's true, we'll keep going. I know they don't have the same version we have, but maybe they do have the green plus. Okay, so anyway, I just wanted to show you that.
Can I ask you a question?
Okay?
Which value did you use for the standard deviation the first one? Or I'm just confused, right?
So we've got a bunch of different standard deviation formulas, right? Which one should you use?
Which ones you use for that? I mean,
What's your question?
it asks for two numbers. So do I do the whole list or?
Uh-huh.
Oh.
Well, how about here? Does it matter which one you pick? It does matter. Which one should you be picking?
STDEV.
Either the SCDEV here, or you could do the .s, right? The .s would give you the same answer. Don't use any of the other ones. Okay? If you want to use the .s, we can do that. We'll give you the exact same answer. You highlight all your data. Okay? All right, now what?
Find the Z-score.
Now we need to find the z-scores, the z for the height. We need to find the z for the heart rate. And I'm going to move all this out of my way because it's in my way now. Okay, how do I find my z-score for my height? Equals, tell me what to click on.
The height.
That's minus
How about the 62
62.
minus
The mean.
The mean.
mean, which is down at the bottom, 67.
F4.
F4, very good on the F4.
Divided.
On my computer.
Do you have a
Divided.
Mac?
Huh?
Do you have a Mac?
No, I have like, but on my F4 it has like a split, like that's the
You
command.
know how to
split
hold the
screen.
function key down as you press F4.
Okay, I've tried like.
What is it for?
It's
Command T.
For Mac, it's Command T. So if you have a laptop, sometimes there's an FN key that you have to hold as you press F4. Okay? All right, now I should be closing my parentheses.
You haven't opened it.
Okay? Don't forget parentheses. That's a great place where people click the right numbers, but they don't put the parentheses in. We're going to hit divide by
standard deviation.
standard deviation, which is below that number there. Do we need to F4 that one?
No. Yes.
So I got F4 on two of those.
Yes.
Okay? Now,
The same.
Alfredo, what do I do here?
Equals 28.
Parenthesis 28 minus
Standard deviation.
Mean.
no, the mean.
Oh, yeah, the mean.
F4. Close your parenthesis. Divide by
Standard deviation.
standard deviation.
So
Okay,
the
one point nine.
X and the Y have two different means and two different
Mm-hmm.
standard
Because it's the heart rate versus the time. Okay?
And now you can just drag the plus.
Now I can drag both of those down. Or you can double click. Like that.
And
Okay.
then you multiply.
Where in this equation do we need the z-score?
This is a z-score equation, and so is that.
So it's just getting to the fact.
Yeah.
And then you multiply.
Then we,
Multiply.
the product, we're multiplying.
Of C rate versus C height.
The 1.48 times the 1.62.
You don't need absolute value.
What?
You don't need absolute value here.
Don't need absolute values, absolute references here. Okay? Gonna copy that down. Then what?
You have to add them.
I'm gonna add those up together. Sum. What's the easiest way to find the sum?
Just highlight it,
Click
look
on that
down.
thing right there. And it's asking, do you want everything above? Yes, I do.
Mm-hmm.
Okay? Yes,
Did you add the two z-scores or multiply them?
and multiply.
Multiply.
Yeah, so as your order of operations, you multiply these two together, then you add. Then you divide by n minus 1. What's n in this case? Is it 22? We have that over here. Yes, it's 22. So we're going to divide by
21.
21 in this case. This divided by 21 gives us a value of negative 0.10. Okay, that's your correlation coefficient. Are you going to be able to solve that on tomorrow, for those of you who are taking it tomorrow? Okay? All right, so my correlation coefficient was negative 0.10. Is it strong, moderate, or weak?
It's weak.
Weak. Okay. How would you find the regression equation?
You have to click
You click on
one of the
So we already
points.
clicked on one of the points,
add trend line.
add trend line. Then what? Go down to the bottom, split the equation. Do you want the r squared?
It's part of the equation.
Sure, why not? I'll put it over here so we can read it. So what's the regression equation?
0.0106.
Y equals negative 0.055 times your what? Your height. Plus 34.792. Let's just look at that so you can see it. Does linear look like a good idea in the scatter plot?
No.
No, I'd say not. What percent of variation is explained by this model?
So 1%,
1%, how did you get 1%?
the R squared.
The R squared value. How do you find the R squared value if it's not on the chart?
Elevate it to the second.
You take that number there and you raise it to the second power. You get the exact same value as we got right here, 106.
So R squared is the percent of variation.
What heart rate would you expect for a person that's 48 inches tall? How would you figure that out?
You plug it into the equation.
Okay, which equation?
The
Zero-
regression equation.
Yes,
Okay.
0.55.
Tell me what to type.
The negative 0.055 times 48
Mhm.
plus 34.792.
Can you keep that equation there for just a second?
We'll do it here in just a second again. Okay? So a person who is 4 feet tall, 4 times 12 is 48, you would expect their heart rate to be 32. Person who is 77 inches tall, so that's 6'5", that's about my size, would be
Just put the same thing in, but put 77.
-0.055 times 77 plus 34.79.
Put minus it.
Mm-hmm.
Plus 34.792. So you'd expect a taller person to have a slightly lower heart rate, 30 and a half. Do you think those are reasonable predictions?
Like,
I have a
based on the pattern, but it's not really good correlation. I don't know how you
Yeah,
answer
it's not very good correlation. Do they seem reasonable?
Well, the
I'd say-
prediction according to what we've got
According
so
to the
far,
equation, I'd say they seem
Yeah.
reasonable. Both of them seem reasonable.
just the correlation's not very strong.
You didn't get like 110 here and 12. Those would not be reasonable, would they?
Mm-mm.
But is this a very good model?
No.
Terrible model. Do you think there would be a better model? Or do you think this indicates that there's no correlation?
No correlation.
There's really not a whole lot of correlation.
Would the equation change if we did a different line, or does it stay the same?
Yeah, if we switch the order, the equation would switch drastically. So here, for example, if I take this and I copy it over here, insert, scatter. Okay. Now notice that doesn't look too different from what we had before. I'm going to pick this, add trend line, equation r squared. I should really do this better. Is that equation different? Yeah, because what are we predicting now? We're predicting their height, not their. No, we're predicting their heart rate, not their height. So the equation's very different. Okay?
Oh, one more time. If you can't find it on the chart, like you said, what's the number that you square to get
Correlation.
the? Okay.
Actually, well, it's up there.
Okay.
For the weak and the strong. the part-
Oh, so you square that.
Square that. Okay, we're out of time. We need to go upstairs and take our quiz. You guys are really scaring me. Are you going to study? Do you want me to post this up on the website?
Mm-hmm.
Yeah.
Okay.